We're looking at homework from section 6.3. This is question number 12. Translate the statement into a confidence interval. Approximate the level of confidence. In a survey of 700 adults in a country, 77% think teaching is one of the most important jobs in the country today. The survey's margin of error is plus or minus 4%. So this is a different kind of problem than what we've done before. Before, we've been given the level of confidence and tried to find the margin of error. Now what we're doing is we have the margin of error and we'll try to estimate what level of confidence gave that margin of error. So that's a different style of problem. Let's look at what we do have. The point estimate, p hat, is 0.77 and 0.04 is the margin of error. 77% is the point estimate, 4% is the margin of error. So we can get our confidence interval by doing p hat minus the error, p hat plus the error, which is 77% minus 4%, 77% plus 4%, which means our confidence interval is 73% to 81%. In decimal form, it would be 0.73 to 0.81. So let's look at the margin of error formula. We're going to use this formula in a slightly different way. We know what p hat is. We know what q hat is. We know what the error is, but we don't know ZC. So let's see how we can solve for ZC. The error is ZC times the square root of p hat q hat over n. We'll insert the values that we know from the problem. So the values that we have are the p hat, the q hat, and the n. So error, which is 0.04, equals ZC times the square root of 0.77 times 0.23 over 700. Since we know all the values except ZC, we should be able to solve for ZC using a little bit of algebra. We'll go ahead and simplify that square root. This ends up being 0.04 equals ZC times this decimal, 0.0159059737. And if we divide by that decimal, ZC equals this fraction, which is 2.514778454. Now because it's a z-score, we're going to round it to 2 decimal places, and we get 2.51. So how does knowing the z-score help us find the level of confidence? Well, remember when we first defined level of confidence, we said that that level of confidence is an area that's trapped between the opposite z-scores. So trapped between z equals -2 and +2, or between -1.5 and +1.5. When we look at a 95% level of confidence and we find that the z-score is 1.96, that means that 0.95 as an area is trapped between -1.96 and +1.96 on the standard normal curve. So really, we need to figure out what area is trapped between -2.51 and +2.51 under the standard normal curve, and then that area will tell us the percentage for the confidence interval. So let's look at a little graph here. We've got a shaded region between 0.251 and -2.51. So we're going to look this up on the standard normal table. We'll look up the -2.51. That gives us the area in the left tail, the unshaded left tail. And then because of symmetry, if we double that, we'll get the total area in both tails. That's not actually the answer we want. We want the answer of the shaded region in the middle. How much area is in the shaded area in the middle? So what we're going to do is we're going to take 1, which is the total area under the curve, and subtract the area of the tails. So let's try to do that. So if z is -2.51, then we need the table value for that. We go to the standard normal table. -2.51 gives us a table value of 0.0060. We need to double that because we need the area for both tails. So 2 times 0.0060 is 0.0120. That's the value we need to subtract from 1. That will give us the area that's bounded in the middle. So the central area is 1 minus 0.0120, which is 0.9880. So that's the area, that's the decimal. If I was going to convert that decimal to a percent, then that percent would be 98.8%. So the confidence interval is from 0.73 to 0.81. We found that back at the beginning. And the interval is a 98.8% confidence interval. And that's your answer.